Okay, so this lesson is on segment lengths formed by chords, secants, and tangents. Last time we talked about angle measures and arcs formed by those. Today we're going to talk about segment lengths. Okay, and there's some relationships when this happens and a few different types. So we'll get into those right away. All right, so the three different types are when you have two chords or secants that intersect inside the circle. Okay, when that happens, then there's a relationship that's formed. And in this picture, you just take, I think it's maybe this arc, that segment length right there. And you're going to multiply the two pieces that make up that segment length. So this would be A times B. And then you're going to multiply that. That relationship should be equal to the two pieces that make up this segment. So C times D. So AB is equal to C times D. Okay, that's if it's inside, if they intersect inside the circle. Now, if you have two secants that intersect outside the circle, okay, then the relationship is a little trickier. This is kind of a good way to think of it. You take the outside piece, which if we're looking at, let's say this segment here, I take the outside piece, that would be A, times the whole segment, which would be A plus B. And that proportionally should be equal to the same thing for this segment, outside times the whole. So C times C plus D. Okay, so that's if it intersects outside the circle. And then sometimes you have a secant and a tangent that will intersect outside rather than two secants. So if this happens, right, we've got our tangent, which is right here, okay? And then we have the secant right here. If that happens, then we take the outside times the whole for the secant. So again, this would be B times B plus C. And that's going to be equal to the tangent squared. So A squared. Okay, so think of it maybe like outside times the whole, which would still be A times the whole would be A as well. So that's how we get to A squared. Maybe that's one way to remember it. Okay, so these are the three pieces that you need to remember and the three different types. Okay, so let's try it. So find each value or measure. Assume all segments that appear to be tangent are tangent. And we're going to solve for x in the first one, and then the second one we're going to find BD. Okay, so now I notice in both of these pictures, they are two chords that intersect inside the circle. Okay, so then I just multiply the two pieces. So I'm going to say 10 times x, and that should be equal to 14 times 15. Okay, so 10x. 14 times 15 is 210. And then if we divide by 10 on both sides, we're going to get 21, right? So x equals 21. So that's how you can find that missing piece using that relationship. Okay, let's try one other one here. Okay, so I'll start with the AC. So we'll say 6 times the other piece, 6, is equal to 4 times the other piece, which is 5x minus 1. Okay, so we have 36 equals 20x minus 4. Add 4 to both sides. I won't write that step out. We get this. And then if we divide by 20 on both sides, we get 2. Okay, now we do need to find BD, right? So if I'll just kind of go up here. I know what x is 2 now, so if I go 5 times 2 minus 1, that's 10 minus 1, which is 9. So this segment is 9. I want to know the whole thing. If B, that this is 4, so then I'd say 9 plus 4. So BD equals 13. I'm just going to stick with my highlighter. So there we go. 4 plus 9. Okay. And that's using that relationship to help us out. All right. Okay, in both of these pictures, we have two secants intersecting outside the circle. So remember then, we do the outside times the whole thing is equal to outside times the whole thing. So let's give that a try. And then we need to find different segments. Okay. Okay, so in this first one, let's say I go outside. On the bottom one, we'll say 13 times the whole thing, which would be x plus 13, is equal to the outside 10 times the whole thing. 42 plus 10 would be 52. Okay, so we'll do some cleaning up now. 13x plus 169 is equal to 520. Okay, so if I subtract 169, I get 13x is equal to 351. Okay, and divide. At 27. Okay, so now we want to find NL. So now I know that x is 27. So if this is, sorry, that's the train outside. It's pretty loud. Okay, so I have 27 plus 13 for NL. So NL is going to be equal to 40. There we go. All right. Let's try another one just to make sure these kind of make sense. This one we need to find YZ. And again, we have the same kind of situation though. Okay, so I'm going to start with 12, the outside, times the whole thing, which would be 12 plus x plus 8, right? So if I add these two together, I'm going to get x plus 20. If I combine the 8 and the 12, that'll give me 20. So hopefully that makes sense to you. And then over here, we're going to do the outside, which would be 15 times. Now if I add these together, I'm going to have x plus 14. 15 plus negative 1, and I can't combine the x, so that's what I'd get there. Okay, and now just do some distributive property in solving. Plus 240 equals 15x plus 210 again. Okay, so get all my x's on one side. Okay. And then I'm going to subtract 210. We get 30 equals 3x. So divide by 3, and that's 10. Okay. Now we need to, let's go back up here. We need to find yz. Okay, well, this is not so bad. So this is 10 now. So 10 minus 1. So yz, I guess I should write it maybe down here. Yz equals 9. 10 minus 1. Okay. All right, I have a couple more, and then we're going to try one that's a little bit trickier. Okay, in this case, we have that last type, where we have a secant and a tangent intersecting outside the circle. So, in the first one, we need to find the length of segment PN, and in the second one, we need to solve for x. All right, so this one said the outside, get to my pen here, the outside times the whole thing, which this one would be 8 plus 5x. So maybe I'll write it out. Okay, so if you're combining like terms there, you should get 8 and then 5x plus 7. Now that should be equal to the tangent squared, so 16 squared. Okay, so I have 40x plus 56 equals 16 squared is 256. If I subtract 56 from both sides, I'm going to get 200. I'll divide by 40 on both sides. So I get 5. Okay, now we need to find Pn. Okay, so let's go back up here. Pn is just 5x. So 5 times 5 minus 1. That's 25. Minus 1 is 24. So Pn equals 24. So these are pretty easy once you know the relationship and how that works. And they can get a little trickier, but for the most part, not too bad. Okay, let's try one more of these types, and then I want to try, like I said, a little bit more challenging one. Okay, so outside times the whole thing. So 27 plus 21 is 48. And that should be equal to x squared. 27 times 48. I'll grab my calculator here. Just to make sure, that's 1296 equals x squared. And then I'm going to take the square root. Okay, now if you take the square root of 1296, you get plus or minus 36. But because we're dealing with lengths here, we're going to use the positive version. So x is 36. Okay. All right. Those are the three relationships. And then I just want to try one a little bit more challenging one. Okay. So this, I notice I have two secants intersecting outside the circle. So remember then it's the outside times the whole thing is equal to the outside times the whole thing. So let's set this up so that we can solve it. All right, so if I do the top one, top segment first, I get 5.5 times the whole thing, which would be 22.5 plus 5.5 would be 28, is equal to outside x times the whole thing, which would be x plus 15. Okay, so that's not too bad. 5.5 times 28, I'm going to grab my calculator for that, make sure, 154. And then I'm going to distribute this over here, so I get x squared plus 15x. Okay, now in this case, in order to solve, I could use the quadratic formula, I guess, but I'm going to try factoring. So I'm going to set this equal to 0 by moving this over to the other side. So we get 0 equals x squared plus 15x minus 154. Okay, now I got a factor. So what are two numbers that multiply to be negative 154, but also add up to be 15? This is a bit of a tricky one. You'd have to play around for a little while, but the two numbers would be positive 22 and negative 7. Again, that take you a little bit of time to figure out, but if you played around a little bit with your calculator, you'd get there. Some of the bigger numbers are a little trickier. Okay, so now if that's the factored form, and then I want to say, all right, what are the values for x that would make this equal to 0? It would be negative 22 and positive 7. Okay, now I can't have a negative value for length in this particular case. So this first one here is not going to work. So this other one is the one that I want to look at. And it says solve for x. So that's my answer there because this distance here is x, and it's got to be positive. Okay, so a little bit trickier one, but using some of your factoring skills, we've done a lot of that this year. So hopefully that makes sense to you. Okay, and that's it. Go ahead and give this a try, and then don't forget to write it into your planner. All right.